Hello everyone and welcome back to video 27. In the last video, I added this internal name argument to the metric base class, which lets you define a internal name for a metric instead of the automatically generated name that gets generated otherwise. And then again, this is just more code that actually returns it. And this actually has a bug in it. It should be self.manual internal name, but I'll fix that in this video. And then for the directory size metric, we have this internal name from args we defined, which just takes a hash of the directories and then appends it to the class name. So this is the default, so that's what we see here. It says directory size and then underscore and then this random thing. This is just the internal name for that particular metric. And then in the show graphs page, I removed the matrix from the document and instead replaced it with this Ajax call. And also, instead of plus equals, we just say dot push. And this graph args is just a list of arguments for each call of make graph. And so down here we have this we get the URL for this new get matrix URL that we defined. And then when that Ajax call finishes, it sets the graph data matrix variable to the returned matrix that gets returned from this URL. And then we loop over each graph arg, which is this list up here, and we apply those arguments to this make graph function, which then actually generates the graph. And then down here we have this new get matrix view. It gets plugged into a URL. And then down here we remove the matrix from the show machine graphs page and instead added it to this new one, get matrix, which is the one that's up here. So in this video, I'm going to fix the problem in the last video where it wasn't getting set, the internal name. So this has to be self, and then also here, I just need to set that to internal name. Now when I do the tick, it's just directory size because it's using that name. And then if I refresh this, it shows the data from before. So now in this video, I'm going to mostly do JavaScript. So the problem right here is this graph. Along here it says kilobytes, which is actually not correct. These are actually bytes. When we do a tick, that gets returned, these are bytes, not kilobytes. So what we should do is, for this metric, we should just say bytes. But that's not, that has its own problem because now it says bytes, and that's correct, but it puts this K here. So, you'd think that it's 114K, so you think that's 114 kilobytes, but that's not true because this is not dividing it by 1024, it's dividing it by 1,000. And, 100,000 bytes is not the same thing as 100 kilobytes. And so I tried looking through the documentation for some kind of option to set where we could, set this, something like scale equals bytes or something that would scale this according to dividing it by 1024. But I don't think that feature exists for this plotting library. So instead, we're going to have to build our own. And so that's what I'm going to do in this video. So the first thing I'm going to do is I'm just going to set the title just underscore bytes. And that's just like a special value that tells the front end that we need to translate these the data into a proper byte unit. And so in the show graphs page, where it says make graph, we'll say if y title equals y bytes, then we will equals, we'll define a new function. We'll call it translate traces 4 bytes. And this will just be a function that takes in the traces, and it will look at the y values in these traces. This has to be called after fill-in traces, because this will look at the y values in the traces, and it will find the proper title that we should use. So like if these values, these values right here are in the kilobyte range, and so the result will be kilobytes. And instead of saying 100K, it'll just say 100. And then this unit word here will say kilobytes. And if the values are in the megabyte range, then it'll say megabytes. If it's in the gigabyte range, it'll say gigabytes. And then it'll have to divide each value by a certain amount to have it match. So now I'm going to just define this function. And so the first thing I'm going to do is find the maximum value. So we want to iterate over each trace and get the maximum value in each trace. So we'll just call this maxes, and then traces dot map, and then we'll say math.max, and then dot dot dot. Instead of x, we'll just say trace. Dot 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 trace y. And we'll just return this. So this is looping through each trace. This dot 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 is the same thing as star in Python. Sometimes you see star arg. This does the same thing. In fact, I can actually, down here, I can just say dot 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 arg, and that would work just as well. This is a new feature in JavaScript. This was maybe added a couple years ago, and it's just a little bit nicer, more modern syntax. And so we're going to test this. First, I'm going to just comment this out. That way I can refresh the page and it'll refresh quicker, because we're just going to use the this console. So we'll do that, and then we'll pass in a list of traces, and I'm just going to include a y. I'll just say 1, 2, 3, 4, 5. And so there's the max is 6. Now I'll just add another trace. I'll just say and there it is, 6 and 8. So it's pulling the maximum of this one and the maximum of this one, and it's taking the maximum value and adding it to a list. And now I want it the maximum of the maxes. So to do that, we'll just say math.max star 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 maxes. And now it's saying 8. So of all these y values, the largest one is 8. And we can now combine these two. Just do it like that. And we'll call this total max. And now the scale of the graph is based on the largest value. So if max is less than 1024, return and then bytes. So the Y title will be bytes, and the traces will be the same as they were passed in. So this means that the largest value is less than a kilobyte, and so we want this y-axis to be kilobytes, or just to be bytes. But if it's larger than 1024, then we need to do something else. So first I'll see if it's less than 1024 squared, which is a megabyte. So if the total max is less than a megabyte, then our scale needs to be megabyte. So we will return traces and then megabyte. But before we do that, we need to adjust the traces. So we need to basically define or divide each value by 1024 to convert it. Well, actually, this is not megabyte, this is kilobyte. We need to divide each value by a kilobyte. So I'm just going to traces dot forward each. And so be trace dot y equals dot map x, and then we want to say x divided by 1024. And then that gets set to the trace. And then we return the trace. So to test this, refresh. And I'll just set these to like 1,000. Total max is not defined. Oh, spelled it wrong. There it is, kilobyte. And if you look at the values, they are divided by 1,000. So this first one is 0.9 kilobytes. This is 1.9 kilobytes. 2.9 kilobytes, 4.8 kilobytes, and that looks to be about correct. And so now we'll do the same thing for megabytes. So it's going to be to the third power. If it's 1024 to the third power is a gigabyte. So if the largest value is less than a gigabyte, then we want to use the megabyte unit. And so this will be squared, and then that's done. So we'll test it. And this time I'm just going to do 1.5 times squared and just delete the rest of these. And the same here. 6.5 times so now we got megabyte. Yeah, 1.5. So it divided it by a megabyte, and then it divided this one by a megabyte. So it's 6.5 megabytes. And so then we can then copy for gigabytes. And it's the same thing, it's just this pattern. And it's not very elegant to keep just copy and pasting this code. So it will be better to just have a single loop that can handle each type. So if you look at each this one's weird. This one's different because it doesn't translate anything because it's the same unit as what it got passed in. It's these ones where there's like a pattern. And so we can just take one of these and just make it generic and then loop over it. So the first thing is this kilo is changed. So we'll call this unit. So the unit changes, obviously. This one was going to be giga. Also, this part right here changes. This is actually 3. And then this here changes to be 4. So I'm going to make a list of these up here. A list of these units. So first is kilo, then mega, and then giga, then tera, and then we can just keep going for each unit, and then I. Then within here, we'll copy this in. And so for this, this unit here is always going to be, so if this, delete this. So in the case of kilobyte, this number has to be 2. But up here, when kilobyte is being iterated, the I is going to be 0. So this will be I plus 2. And then down here, the exponent is, so this exponent keeps going up by 1. It starts off, it's just going to be 1. So we'll say it should be I plus 1. And then that's it, that's done. So I can delete this. And one more thing. Now that we have this return, it's not, what we want to do is return from this function. But we changed this so that we have this instead. So now when we hit return, it's going to return from this function. And this for each, what we really want to do is we want to break. We want to mark this value as the correct value that returned, but we also want to stop the loop. And this for each, it ignores this return. So, which is kind of annoying. Like in most languages, you have a way to break out of a loop, but when you're using for each, there's no way to break out of a loop. So, well, there is a way, but you can like raise an exception, but that's kind of not the best way of doing it. So instead, there's something called sum. And what this does is it's very similar to for each, except it'll stop iterating when you return true. So once true happens, it returns, and which is what we want, which is what it was before. It was just a return. You loop down the list until you find the correct one, the correct unit, whether it be kilobyte or megabyte, and then once we have that, we return. And so to get this data back, I'm just going to say ret. I'm just going to create a variable called ret. It's just return value. And once it returns true, it kicks out of the loop. And then return ret. And so now we'll test it. There it is, megabyte, it's working. Now if we change this to 3, this is 1.5 gigabytes and 6.5 gigabytes. So now it says gigabyte and 6.5, 1.5. And then we could even try terabyte, and we can keep going, but I think these are probably good for now. And now we'll just re-enable the graphs. test it and see if it works. There it is, kilobyte. And it's showing real kilobytes. And to test this, I'm going to go to the to-do folder. I'm just going to move a file called megabyte. I'm just going to move it here. And it's just a file that's like 2 point something megabytes. Yeah, it's like 2.8 megabytes. And so now I'm going to make a tick. And there it is right here. This is 2 point something megabytes. Now we'll refresh. There it is. And it's now a megabyte scale. And it's showing about, can't get it to, I have to zoom in. There it is, 2.8 megabytes. And then I have another file, it's called gigabyte. It's a gigabyte file. I'm just going to move it into this folder. And the gigabyte file is 1.2 gigabytes. And so we'll make another tick. And refresh. And it should say gigabyte now. There it is, gigabyte. And the value up here is 1.24 gigabytes. That's correct. And here it says 1.3. So if we didn't do this, it would have said 1.3 G, which is not correct because it's 1.2. So that's just because this by default divides by 1,000 instead of 1,024. So now it's just more accurate. And that's going to be it for this video. Yeah, not these. In the next video, I'm just going to build more metrics and also work on that alert feature where it'll alert you when a value is greater than a certain amount. Yeah, so I'll see you next video.